Hello and welcome to this next video. Hopefully this will be in the new year now by the time you see this. So this video is sort of an advanced section of the chapter 7 in Pure 1. Alright, of the algebraic methods stuff. Funnily enough, it has the same title as such. Actually, that says just algebraic fractions and partial fractions. Now, the problem with this is it's only covered in second year. Now, I liked, when I teach this, I group chapter 7 and Pure 2 chapter 1 in the same time. I group them together as such. So this is kind of going to be an extension video of the algebraic methods that I did for Pure chapter 7 of Pure 1. Alright, that's in Edexcel anyway, because that's the board obviously I'm going off. So, this is Pure Year 2 chapter 1, and we'll have a look at it. So, algebraic fractions then. First of all, what is an algebraic fraction? Funnily enough, it's got algebra in it. How could you guess that? But to look at algebraic fractions, let's have a look at 1 over 7 plus 2 over 14. I don't know, put 3 over 14. I know you can add those together. I'm not going to insult your intelligence so much. But that will be 2 over 14. That will be 3 over 14, and I get 5 over 14. Nice and easy. Alright, but what is the method that I'm using here? I'm finding a common denominator. And when we add algebraic fractions together, we're going to use this method of finding a common denominator, which is why I want to get you back into the swing of these sort of questions. So, we'll have a look at this one. This example will say that if I had, say, 4 over x added to 5 over x squared, how could I combine those together? Well, what could I combine them together? Well, this I'd have to multiply by x, wouldn't I? So this whole term will get multiplied by x. So I get 4x over x squared plus 5 over x squared, which I can say that's 4x plus 5 divided by x squared. Okay, so I've done that. So I'm using this idea of a common denominator to add them together. Now, if I wanted to multiply these together, so if I wanted to do 4 on x multiplied by 5 over x squared, well, I'd just multiply them like I would multiply numbers together. So I'll do 4 times 5, which gives 20, and x times the x squared will give us the x cubed. If I said, for example, I wanted x over 4 times x squared over 5x, doesn't really matter, it could be anything, right? I could say that it would be x cubed over 20x. You see what I've done there. Dividing them works in the same way, 4 over x divided by x squared over 5. Well, remember we've got the flip. We've got the stay flip change rule as such. So we flip it and we change the sign. So we do 4 over x and multiply by 5 divided by x squared, which will give us 20 over x cubed. So this is this method that we're going to use in order to solve some of these kind of problems. Now, I'm not going to go through tons and tons of examples of these because I'm pretty sure that you can do this pretty well here on the A-level maths course. You should be alright with these. The real thing that I want to spend the most time on today is looking at this idea of partial fractions. Now, where on earth does partial fractions come from? Partial fractions comes from, remember at GCSE, I would ask you, combine them together, please. Off you go, and you spend about 5 minutes combining them. Yeah, we can combine these together using cross multiplication, can't we? So we get 4x take away 8 plus 6x take away 6, x minus 1, x minus 2. And then I could tidy that up, that'll give us 10x minus 8 take away another 6 will give us a minus 14 over x take 1, x take 2. And that'll be your final answer. Well, what if I told you you can go the other way? All the way back. This is the idea of partial fractions, and that's what we're going to explore. So if I wanted to write this fraction, so example, e.g., write 10x minus 14 over x take away 1, x take away 2 as partial fractions. I'll give you a minute to think about it, and then I'll go through it. Okay. Right, so hopefully you pause the video. There we go. There we go. Okay, so I use for partial fractions this method called substitution. And it's quite a useful method because if I wanted to write this as partial fractions, well, 10x minus 14, x take 1, x take 2, well, that's just some number I call a plus some number b, or my other fraction. I know that from this original one here. I know it's going to be some number. I don't know what this number is, but it could be. And then I cross multiply, as I would. So the x minus 1 and the x minus 2, when I multiply up there, will cancel out, so I don't even bother writing them. So I just get the 10x minus 14. And then I multiply those up. So I've got an x minus 1, so those will cancel, so I get the x minus 2. And a b will get us the x take away 1. Reason why is because it's a cheeky rule, and it gains what the other one doesn't. So if this is an x minus 1, it doesn't have the x minus 2, so it'll gain that. You feel me, right? You feel me vibe, right? So I then say, well, let x be 2 and see what happens. Because I know if x was 2, then this will be 0. So I can find what 2 is in here. So 2 take away 1 will just give me 1, so 1 lot of b. And that'll be 10 times 2. 10 times 2 is 20, take away 14. Well, I can do that in my head, that's 6. Oh, hang on a minute. Well, 6 over x minus 2. I help. I got that up here. So we can see this method using. It's brilliant. Then I want to say, well, what is 1? If x was 1. So when x is 1, well, we get 10 times 1, 10, take away 14, minus 4. That's easy, I can do that. And sum it into here now. 1 take away 2. 1 take away 2, well, we're going to get here, what's that, minus 1? Minus a? Yeah? Well, if minus a is minus 4, then what's a? Well, when x all cancel out, so I get 4. Oh, hello, I got 4 up here. So you can see this method working out, and I use this a lot. Alright, in integration, we might cover some examples with integration. I don't know if we'll do it in this video because this video is kind of separated out, but this might be a part that you might want to come back to when you're doing integration with partial fractions, which is chapter 11, I believe, in Pure Year 2. Alright, so you might want to come back to this stuff again at some point. So hopefully this is sinking in. I'm going to do one more. Please, could you write, have a go at this as well, 6x take away 14 over x take 1, x take 2, x take 3 as partial fractions. Give you a minute, off you go. Okay, that should be enough time. Let me go through it. Hopefully this is getting rudimentary now. So 6x take away 14, you might even jump to the next line. I usually do this a lot. So it'd be a lot, so x minus 2, x minus 3, plus b lots of, well, that'll be x take 1, x take away 3, and then I add c lots of x take 1, x take away 2. Next step, yeah, let x be some values. So if we had x was 2, well, if x was 2, we get 2 lots of 12. 2 lots of 6 will be 12. Take away 14, that'll be minus 2, won't it? So that bracket will be gone, and so will that. So it's just this bracket now, isn't it? these other two. If x was 2, then I'd get 2 minus 3, so it'd be minus a. Then if I sub 2 into that one, I get 2 take away 1, which is 1 lot of minus 1, so minus b. And then the 2 will cancel that out, so that'll be that. So I can't solve anything yet. Will x be 3? 3 times 6, 18. Take away 14, well that'll be just 4. The 3 will give us just a plus 2b plus 3 take away 1 is 2, so it'll be 2c. Then what else do you want to let equal to? Well, let's pick the easy one, pick 1. So 6 lots of 1 is 6, take away 14 and give you minus 8. So 1 minus 2 gives minus 1. And then multiply that by, so it's minus 1 times minus 2, which will just give us 2a. Yeah. Then if I sub 1 into there, I get minus 2b. And then if I sub 1 in here, I get, well that's just 0 into it as such. Yeah, so I don't even need to sub that in there. That'll just be 0, won't it? Now what am I doing? Hold on a minute. Because if x was 3, that'll be gone, so it's just that. And if I sub 2 in there, that's gone, so it's just that. Which is just that. That's what you should get. Now to solve these. B is 2, C is 2, and A is, minus 4. So 6x take away 14 over x take 1, x take 2, x minus 3 can be written as minus 4 over x minus 1 plus 2 over x minus 2 plus 2 over x take away 3. Okay. That's how we can do this example, this partial fraction. So, I've got one more, but this one is cheeky. Let's have a look. Okay, in this video, I'm going to do this example of partial fraction. We have 5x squared plus 16x minus 3 on x minus 1x plus 2 all squared. So we've got this repeated factor in the denominator. Now your first thought, I bet 100%, is say, well, okay, that's a on x minus 1 plus b on x plus 2 all squared. And you might think, yeah, I know what that means, yeah, I can do that. Actually, that ain't true. It is not equivalent to that. Alright? It's not at all, because when let's go back to GCSE for a moment. At GCSE you might have got a question saying, you won't get it this simple, but you get like 7 over 24, and 24 you could write as its product of prime factors, right? So you'd have 12 and 2, 12 could be another 6 and a 2, and 6 is just a 3 and a 2. So that could be written as 7 on 2 times 2 times 2 times 3, right? Which could then be written as A on some number 3, plus B on, well, what would come next? Would it be a 2? Could it be 4? Could it be 8? We don't know what this number could be. It could be a 2, could be 4, could be 8. Don't know. Alright? So we have to put another thing like a sponge as such, which is going to soak up that extra bit. a bit like if you're doing linear programming and you want a slack variable, you want that extra bit to soak up whatever's there in a inequality, or an equality is when you use linear programming and all that jazz. So what we're going to have is, this isn't true, so we're going to get rid of that, but we're halfway there, we've done half the job. All we have to write is a on x minus 1 plus b on x plus 2 plus c on x plus 2 all squared. So we've got 3 brackets to deal with. Now we multiply up by the denominator here, so we get 5x squared plus 16x minus 3 is, actually no, don't put 3 lines when you're doing this. I was going to put 3 lines, but it's not technically true for all y of x, isn't it? So we've got a lots of x plus 2 squared plus b lots of x minus 1 times x plus 2 and c times by x minus 1. Should not be there. Okay. So what we want to do, let's say let x equal 1. Well, if x was 1, we get 5 plus 16 minus 3, which is 18. Now, a 1 will knock that out and that out, so it'll enable us to find that. 1 plus 2 is 3, squared will give us 9a. That's nice, because that'll tell us that a will be 2. So a we can put in as 2. Brilliant. Next, let x be minus 2. Because minus 2 plus 2, which is 0, all squared, which is 0, so that bracket will cancel out. So we get minus 2 plus 1, which is minus b, minus a, oh, actually no, minus c actually, should I say. Minus b minus c. In fact, no, that should have an x plus 2, you donkey. Because, yeah, you get minus 2, won't you? Times minus 1. Yeah, so we'll get minus c. Now I don't know what that is, so I'm just going to go fetch the calculator one moment. Yeah. Right then, calculator. Casio class was fx991ex, of course. 5 times minus 2 squared plus 16 times minus 2. Take away 3, which is negative 15. Got my pen out here. Negative 15. And then when we sub in minus 2, that will go, minus 2 will get me minus 2 minus 1, which will give us minus 3c. So that means that, not ac, is positive 5. So it's that extra bit that we had. Then you might think, well, why am I letting x be 0? Well, if I let x be 0, what's going to happen? Well, if x was 0, I can find out all the rest of these terms. So I get minus 3 is equal to 0 plus 2 squared, so we forget 4a. Then we get 0, take away 1. So we get minus 1 times 2 minus 2b and c, x minus 1. So 0 minus 1 be minus c. So we get minus 3 is 4 times 2 minus 2b minus 5. Onto the calculator here, we've got minus 3 is 8 minus 2 that, minus 5 that. And so we find out that b must be 3. Okay, so this is the hardest example that I can think can come up in an exam. Now, when I'm recording this, the 2022 exam dates are soon to be released now. I am predicting this is going to be on it. I'm not sure, but they usually put at least one partial fractions on across the 3 papers if you're on the full A-level scheme. This is the full A-level scheme of work. Now in further maths, I've already done a video on LL partial fractions, LL further maths partial fractions, and I say you need to come and watch this video on LL maths before you go and do the further one. Now the further one will probably come up because they do it with integration, but with a quadratic in one of these factors. Not too much different. I will do it as part of this video as an extension, but I already have that on this channel, so I don't want to make too many videos of the same content, which kind of makes no sense. Alright, so thanks very much for watching this video, and I shall see you all in the next one. Bye bye for now.